Really Dead Hands-On with Gemini, new 1 million token context window. My name is Yukti Divedi. I'll be your moderator today. And one of my main jobs at SingleStore is to organize weekly AI webinars. We organize 2 webinars per week and we showcase data and AI use cases with different tools and technologies, latest in the market. And I will start posting about these upcoming webinars every week. So if you guys are interested and if any of this is interesting to you, please feel free to connect with me. So like you can stay on top of the loop. And also I'd love to hear your feedback or any ideas on topics that you'd like to see in future sessions. If you feel like we can improve in some way, I'm very open to suggestions. Please hit me up and all right. So speaking of future sessions, we've also got several amazing sessions coming up over the next few days. I'll be putting everything in the chat. On April 30th, we have Meet Llama 3, run locally with more power, less cost, full privacy, with Alex Peng, who's a growth engineer at SingleStore. He's very knowledgeable. He's from Stanford. It's a must attend. And on even Vinija is from Stanford. She's done a very amazing AI course. And kudos to that. And then like on 2nd of May, we have world's fastest LLM with Grok and SingleStore. On May 3rd, we have AI ML driven forecasting power for power demand supply and pricing with Ayush Pai, who's a computer science student at Georgia Tech. If any of these topics are interesting to you, please RSVP right now. I hope to see you all there. All right. Just let me put everything in the chat for you guys in case you want to check anything out, and then we can get to today's topic. Everything is in the chat. Welcome, everyone. Really value your time and energy. Thank you so much for joining. Okay, so back to today's topic. You're welcome to participate in the discussion throughout the session using the Zoom Q&A button at the bottom of your console. We also have an internal mission statement to try to answer all the questions that we get, and even if that means like following up with folks afterwards via email, because this has gotten increasingly difficult over time, because sometimes we get hundreds of questions per webinar and it's like very difficult to take all the questions live, but we are absolutely up to the challenge. So please make sure you have logged into Zoom with your name and your email address, because we won't be answering any anonymous questions. And even if your question is not taken up live, we will definitely follow up with you. uh, Also, we'd also like you guys to have a more dynamic experience, so please try SingleStore DB and have a chance to win either branded new AirPods Pro or Meta's new Ray-Ban LLM smart glasses. Your choice. Can someone share the screen? Like Vinisha, there is a slide regarding
Yep,
that.
absolutely. Let me
You
share that.
start sharing the screen and like that will
Let
give
me
more
get on
clarity.
present.
If you try now, yeah, this is what I'm talking about. If you try now by clicking on this link, I'll just put it here. Yeah, if you try now using this raffle link, you will be enrolled to have a chance at winning the following prizes that are mentioned in the slide. And it's absolutely your choice. If you're shortlisted, we will ship these to you. And uh, this will also help you to leverage the webinar in the most fullest way possible. And you know that SingleStore has had a free trial offer for many years, but in the past few weeks, we've also announced a free share tier, which we'll talk about a bit later today. So, okay, moving forward, please allow me to introduce our amazing speaker today. Vinija is a machine learning engine leader at Amazon, and she is an author on many research papers with a formal education in AI from Stanford. She has expertise in big data, machine learning, and AI, and she has created some amazing new AI demo applications that she showed off during our company's kickoff in Scottsdale last month. Congratulations, Vinija. It was really amazing. You're such an inspiration. Okay, the floor is now yours. Please start away. I'm so interested in listening to what you're going to present today.
Absolutely. Thank you so much, Yukti. And thank you so much for the introduction. And thank you so much for everyone joining here. So I'm just going to start off with a brief introduction on myself, and then we'll go over the agenda, what I have planned to go over today. So I'm Vanija, like Yukti mentioned, and I've pursued AI at Amazon. Prior to this, I was at Oracle, Palo Alto Networks. I've started my career off at Stanford, where I've taken NLP, machine learning, meta learning, a lot of different courses, which is really grounded my foundation in AI. Along with that, I also write a lot of articles, and this one in particular has been a very hot topic in industry as well as academia recently, is RAG dead, especially with Google's Gemini coming out now with 1 million context token length. So that's what we're going to talk about today. Just going over the agenda quickly. We'll start off by first talking about what is retrieval-augmented generation. Then we'll dig deeper into what is Gemini and its context length. Then the question we've all been waiting for, is RAG dead, and figure out what we think based on our learnings here. And then a quick demo here using Gemini Pro. All right, let's get started. So RAG, just a quick overview of RAG. What is it and what does it do behind the scenes, and how SingleStore really helps power it. So what RAG is kind of an external knowledge base that you feed into the LLM in order to really enhance its abilities to generate the output. How we do that, there's several different ways to do that, but the basic vanilla procedure is that the user will come in with a query, a prompt, we'll look to embed that information, and then once we have that information embedded, we'll look at our different vector databases that SingleStore provides here, and in the demo, I'll show you how to leverage that. We'll find a similarity between the user's query as well as the context within our vector database. We'll retrieve the relevant chunks from the database. We'll come back to the LLM, attach the prompt plus the query plus the enhanced context that we have gotten from our database, and then the LLM will have enough information to generate that response. Essentially, what it's looking to do is it's looking to really power up the LLM's understanding in order to eliminate hallucination and eliminate any false feedback going on there. So like we mentioned here, there's a 4-step procedure. The user prompt gets embedded. You can chunk the data and embed it with an encoding model in the SingleStore database, in the SingleStore vector database. Then you'll do a semantic similarity match using approximate nearest neighbors based on what input the user has given, and then what the vector database will return is what is leveraged to actually output the generation from the LLM. So what is vector search then? What do we really mean here by vector search? Vector search is within the database when we're trying to retrieve the relevant query from the vector database. And imagine in this vector database, you have PDFs, articles, you can even have multimodal setup, which we'll see with Gemini soon, where you not just have text, but you have images, videos, and you want to retrieve the most relevant artifacts to the user's query. So what you'll do is you'll employ these algorithms that perform the similarity searches in these high-dimensional vector spaces here. And it really helps enhance the complexity of the queries. So how we do this is we first embed and use embeddings in order to convert the text, images, audio, whatever you have into the vector space. And then we run the similarity comparison here. So there's different applications here of the vector database. You have semantic text search. You can leverage them for recommender systems. You can leverage them for image and video retrieval and retrieval-augmented generation as well. So also wanted to touch on how SingleStore runs their queries on their vector databases and how it's very unique and very easy to leverage, especially if you have experience writing queries before vector databases. So the syntax is very similar, create table, very self-explanatory there. The actual novelty here is the dot product. Now, like we mentioned earlier, the dot product is used for similarity match between what the user's query is and what's within our vector database. that's what we want to do when we're leveraging the vector database. We want to pull out the similar items. Now, SingleStore allows you to also pull out different metadata that you want to from your database. So I specifically want file names. I want to have them sorted on the dot product. And once I do sort them on the dot product, I want it to be visible as score. And then we're looking at the people table and we're ordering it by the score in descending order and limit it by 5. Very self-explanatory, very easy to use. We'll see that in the code today, but this is inherently built into the SingleStore vector database. So I would definitely urge you to play around with that once this session is done. And just a quick history on how the vector search evolved in SingleStore. So in 2017, vectors were actually stored as blobs. You can think of S3, something similar, synonymous to that. So they were, for similarity measures, they were using dot product, Euclidean distance, exact KNN match, and they fully integrated SQL with it. You can imagine with the exact KNN match, the latency would have been a very big issue there, which is why now we've reverted to ANN, which is approximate nearest neighbor match. So with a little bit of lack in efficiency, you gain a lot in terms of latency. In 2022, as ChatGPT started to generate a lot of interest, this space became even more relevant and needed. And now, because of that, in 2024, ANN search and vector type is completely embedded within the SingleStore's vector database. And we can leverage it and we can query it as we saw previously. So just a quick word on why we should use SingleStore for vector search. There's many reasons, simplicity being one of them. The free tier they offer, where you can honestly create a lot of applications and run through just the entirety of the vector database, as well as the notebooks itself, and get a really great hands-on experience on how to see that. But outside of that, the many features it offers from SQL, transactions, analytics, vectors, and text search, all in one easy-to-use place, and integrating your database, getting it up and running. They really eliminate all of the hard configuration steps that can really drown you out and really help you focus on what matters, which is actually running your application and running your code as smoothly as possible. So let's now talk a little bit about ANN indexes and how they work with search. So like we mentioned earlier, ANN is approximate nearest neighbors. So what ANN really looks to do is, as the query comes in, as the user's query comes in, it looks to find the embeddings and the embeddings as approximately close to the ones that are most relevant to the user and their query. And there's several ANN indexes. There's inverted, there's IVF flat, IVF PQ, IVF PQF, all of these available at large. And what SingleStore really helps you do here is it uses the indexed ANN search when there's a larger vector data set. That's really where its power comes in. It reduces latency and it gives you results as quickly as possible. There's high concurrency, and when there's no need for perfect recall, when there's no need for a perfect, precise answer, ANN is the best approach to use. Let's also talk about distance metrics a bit. And in terms of distance metrics, this is the same thing as the similarity measure that we were talking about previously. This is very important in the vector space because this is what we heavily rely on in order to get our answers, in order to get the most relevant answers back, especially within RAG, Retrieval-Augmented Generation. So there's several different ones. Distant metrics, there's dot product, there's cosine similarity, Euclidean distance, similar to Manhattan distance, Hamming distance. As you can see right here, there's a variety of distances metrics that are available in order to really measure your query and the similarity between your query and the output text. And each of these KNN or ANN algorithms only work for certain distance metrics here. So that's one thing to keep in mind when you're building your RAG applications. Now let's look at vector data types a bit. So previously, once we were leveraging vectors as blobs, so this is the syntax we use. The column names were all blobs. Now, SingleStore has modified that into having them being leveraged as vectors, as actual vector types, which is very powerful in the backend to be able to store all of the embeddings as vectors, and couldn't be easier. Just replacing blob with vector and your size there, and type. Very easy to use, and it comes with a lot of benefits here. It's very readable. So in a sense, it's self-documenting. You don't have to specify what you're looking to do. When you start typing these, there's compile time error checking for the length and the type mismatch, which is amazing to have that error checking before you actually hit the error and have to debug the whole system. And it also enables autocasting to vectors, so less work of typing everything out there. And here's the syntax as we saw earlier as well. This is the dot product. This is the similarity, the distance measure that SingleStore leverages, and it's as simple as just this syntax in order to call the dot product. So like we saw, you can select different meta types that you want from the database. Right here, I just want the file name and the score. And in order to get the score, I want to use the dot product there. And I want this from the table people. So once I have the syntax like this, SingleStore will automatically cast it into the vector types because it understands that's what you're looking for. So this gets converted into create table embedding with the ID type int, and then you get your vectors created as well. And then you insert the embeddings actually as values. As we know, this is what the embeddings look like internally. So it's not only readable, but it's also able to automatically cast it into a vector space there, which is amazing, amazing feature there. The other thing that SingleStore is able to do is also cast to and from the blob that we saw earlier. So, and this is implicitly done. So it's implicitly able to cast from both vectors to blobs and blobs back to vectors. So just a quick example of how this works. So let's say you create or replace a function here, and you're looking to normalize, and you start it with blob, and this returns blob. So you'll have your full syntax begin, end. Then what it'll actually do in order to cast it, what it'll do is all you'll have to do is say, set this variable, have it be vector type, set this variable and normalize it to vector type and size. It's very readable, very easy to use. The similarity measures and the similarity operators available in SingleStore are not just limited to dot product. We saw the syntax for dot product. There's also Euclidean distance, and the syntax is just a dash instead of a star there. So very easy flip there. And then for vectors length of 1, there's cosine similarity with that syntax, with the star syntax, dash syntax for the Euclidean distance. One way to figure out which application, which similarity measure works best for you is just trial and error with your application, seeing which is giving the best results, which is really pulling out the most syntactically similar vectors from your database there. And again, there's many benefits to using SingleStore as your vector database. Not only is it a vector database, it's actually a full power SQL database as well. It has transactions, parallelism, scaling out. It's able to do new vector queries as soon as the transactions are committed. There's also hybrid search, which we'll talk about in a bit as well. And the hybrid search combines both the vector, the metadata, as well as the original text search, which is very powerful. You're not only able to leverage the vector database, you're also actually able to do your text search. And the speed to match the search, to match that of the vector-only databases, it's able to do all of that and match the speed of the other vector databases, and it's faster than the other ones available on the market today. So yeah, also wanted to quickly talk about the SingleStore free tier, which Yukti had mentioned. Free tier offers a plethora of different tools and applications that can really help you bolster and kickstart your application. It has low latency performance. You can do multimodal queries, as we'll do today, actually. We'll see how to leverage that. It's a very easy to use setup. The notebook, the database, everything is available in one place all together, easily configurable. And SingleStore also gives you a $600 credit to start off with in terms of compute. And we know compute, any help can go a long way, and $600 really goes, helps a lot there. So SingleStore's free tier offers notebooks, the SQL database that we had mentioned earlier, the vector database, gallery of starter codes. Actually, this is an amazing place to start off, even if you're just getting into the AI field and you're not really sure how to start off, how to code something, or you just want a template of a current application and then you want to build on top of that. Their gallery of starter code is a very, very rich environment that I haven't been able to find anywhere else. They have a lot of great stuff there, starting from how to work with Llama, how to work with different models, how to do RAG, hallucination, so many different applications of AI there that I would definitely recommend checking out their gallery of code. They have support, monitoring also built in, a lot more. So definitely would recommend checking out the SingleStore free tier. And just a quick preview on what it looks like. So like I mentioned, very easy to use. This is the environment that you walk into. If you have any recent notebooks that you've worked with, you'll see them here. They also provide you different suggestions. Maybe you're not sure on what to work on. You're able to build multimodal AI applications, recommender systems you're able to build, so many different things. The gallery is right there on the side. This is how you'll connect to database and the cloud and any other things that you may need to connect for your application. These are the development environments. You have your notebook, SQL editor, and you can also customize whether you want your notebook to be in personal, private, or shared, and you can share it with your organization. Monitoring, there's a lot of different types of monitoring. There's workload monitoring, there's active queries, historical monitoring, alerts, everything you'll really need to make sure that your application is up and running. And then there's pipelines as well, which helps you run it end to end. So very easy feature here to use and would highly, highly recommend checking it out. And hybrid search as well. So hybrid search, like we mentioned, is the combination, and it's the best of both worlds. It takes both the vector as well as full text search and merges them together without lacking in performance and without hindering in the latency there. SingleStore is able to combine both of these together, and the results are incredible. So you don't have to choose between only doing vector search or only doing text search. They provide you the availability to merge in both there. So now let's get into the depths of the topic for which we're here today. So is RAG dead? And let's look at it in the context of Gemini Pro, since it does have the million context length. So first thing I wanted to do is kind of go over Gemini Pro and the cost of how it's used and what actually involves in using Gemini Pro. So the price difference, as we notice here, is quite stark when you're looking to leverage Gemini Pro. It's about $7 per million tokens, and utilizing all of these million tokens with every call is what you'll kind of pay for here. And this is for 1.5, which has the 1 billion token there. So the price difference here is quite stark. With RAG substantially costs less than using 1 million tokens within Gemini 1.5 Pro. The cost per call with RAG is a fraction of that $7 required for every query that you run in Gemini 1.5. And think about it in this way. If you have critical applications, if you have applications that need to have queries coming in every second, every minute, the $7 can really add up there versus having a storage system, having a vector database with kind of stagnant or even updating those the database itself with different chunks, different texts, different PDFs, images, can cost substantially lower than running Gemini. Also, in terms of practicality, if your application does not require leveraging that 1 million context length for every single query, it might not make sense to pay that amount. And we'll look at other differences and other practicality aspects of leveraging Gemini 1.5 here as well. So looking at the other applications and the other kind of fundamental differences between using RAG and Gemini is the cost. The cost is probably the biggest piece here. So RAG, what it really looks to do, it looks to have the selective snippet kind of retrieved from the vector database. This makes it really economically viable for frequent use applications. So say you have a chatbot, say you have interactive tools, or even within your organization, you have an application that needs to be hit frequently, multiple times in a day, in an hour. The cost can be quite high, and you may not get enough ROI from using Gemini 1.5 versus using RAG. So the discussion here is that with its 1 million context, instead of having to store all of the information within the database, you can just present it to the LLM at once at the time of querying. Now, there's also some latency that you'll face there as well. Every time a user is looking to ask for a query or ask for image generation or text generation, they'll have to be able to provide the full context, the full information to Gemini in order to get the result. This may cause a lot of overhead as well. You may have to have applications running to make sure that you're feeding in all of the information correctly every time that there's a query there. So there's also that practicality aspect where it might not make sense to use Gemini over using RAG. There's also the talk about accessibility. With its high cost, it reduces its accessibility. So it's not able to be used in, say, education sector. So schools cannot leverage it, right? Small businesses can't leverage it. Startups are able to adopt RAG without facing these high costs. So startups are able to get up and running with their businesses with RAG, but they may not be able to kind of provide the cost needed for Gemini here. The other thing is the versatility across domains. So RAG is effective in using, and it's used in diverse areas. RAG is used in customer service applications, educational tools, content creation, without the significant financial overhead. Now, every time you want to use Gemini 1.5 Pro, what you'll have to do is every time you want to switch context, perhaps you want to go from customer service to an educational tool, you'll now have to keep providing it that new context in order for it to understand and then be able to provide you with better answers. Whereas in a database setup, once you have chunked all of your documents, all of your input material, all of your assets, it's there forever, and it's staying there stagnant, versus having an LLM that now you have to, every time you want to talk about something else, something very domain specific to you, you have to keep providing that context over and over again. So you'll have to have applications running synchronously providing that. And then the other thing is there are efficient updates with RAG. So RAG can quickly adapt to changes in data by pulling from updates or expand a database without needing to retrain the entire model. If you have ever changes in your database, say your document has changed, you've added new products in your organization, and you need your system to be able to be aware of those, all you would have to do in the RAG use case is update the database. You would have to embed your new document, find the same chunking strategy, store it within your database. Those are all the steps you'll need to do in order to update the vector space. And then once the user query comes in, it should be able to be matched with your new information with the same similarity measures that you've been using prior to this. Now, say that for some reason, the context you provided to Gemini is still not helping it get the best output and the best answer out there. Retraining the model is not an option there. Being able to kind of adapt, being able to even maneuver or even kind of change anything in Gemini is not really an option. So all you'll have an option to do there is keep changing the context you're providing to the model. And this trial and error can again be very costly as you're looking to get the best output result there. And lastly, but possibly the most important, is hallucination. LLMs have tendencies to hallucinate. With a multimodal model like Gemini, the hallucination can span over modalities. So it doesn't only have to be in text, it can also be in images that it outputs. Trying to mitigate that, trying to just minimize that, that is also something that Retrieval-Augmented Generation can help with. And unfortunately, there's no one answer currently in industry in order to completely eliminate hallucination. So there's still a possibility that this can kind of come through with Gemini in some use cases, which can be quite detrimental to your organization. If you have say a support application where a user is looking to figure out how to use your product and Gemini hallucinates the results or the instructions there, will cause a really bad user experience. So there's also that aspect to look into. So in terms of scalability, practicality at the current moment, I would not say RAG is fully dead. There's definitely places for leveraging the large context length if your use cases fit that. So if your use cases require large context length, very, very large context lengths being inputted in order to get your exact outputs, and cost is not an issue, and perhaps you don't have the context changing, so you don't have a lot of versatility across domains, then perhaps that way is the best way to go for you. But until then, in terms of practicality, I don't think RAG is currently dead. So with that, let's now transition over to the demo where we'll look at Gemini 1.5, and we'll look at both text and video, and we'll do a comparison of RAG and then feeding that same context into Gemini itself. So let me get over there. And my screen is still visible, correct?
Yes, we can see your screen.
Awesome, awesome. I'm just going to increase the size here a bit. Okay. So is RAG dead? And so just a quick introduction here too. This is the SingleStore's free tier. Selecting the database couldn't be easier. It's just a drop-down click. You can save your code. You can also export it. You can have it pushed to GitHub. Here's the gallery. Here's all the different tools we talked about. It couldn't be easier to use here. And you can run all of your applications. Very easy to use, very customizable. So now let's look into our demo here with IsRagDid. We'll walk through all of this code. Some of this I've run previously just to save time. As you can imagine, running the context within such a large model can take quite a few minutes. So we have that output already done. So now let's go through line by line, and you'll be able to get this code after this session as well. So you'll be able to run through it as well. You'll start off with putting your key. I've just put a placeholder here. This is not my key, but you'll switch this out with your Gemini API key in order to get started here. And then the setup here just involves having all of your packages installed. So for us, it's PyPDF, since we're going to be leveraging a PDF here. And what we're going to start here with is doing a text input into Gemini. So the first half of this code, we're going to look at prompting Gemini, filling up its million context length, and filling it up in multimodal setup. So we're going to fill it up with text as well as a video. And then we're going to see its output and how it performs. Then after that, we're going to run that in a RAG use case using SingleStore's vector database. So here, first, we'll start with prompt. So like I mentioned, we're going to be prompting Gemini with multiple modalities. So what we did here is, this is a PDF reader. So we're loading a PDF from a URL. The URL I used here, which I believe is the State of the Union address. So this is the link I got it from, and I loaded the PDF, and just so we can see what the contents of it are, I've just printed it out. So this is what the PDF looks like. This is the text within the PDF. It's just the State of the Union. Awesome. Now, what we're going to do is, for Google, we need to leverage Vertex AI as well as generative AI. There are two packages here, so we'll install them. Have that running here. And now, once you have that, now we're going to look to see how to first just do a text prompt as well as output to Gemini. So what you'll have to do here is, once you've imported those packages, you'll want to generate the response. In order to generate the response, we just need to make sure that the key we have is activated. If it's not activated, if there's some issue with the key, we throw the error here so that later on, if we run into some issues, we know that the error is with the key, not something else. So just for our own debugging, we'll do that here. Then once we know it's good to go, we'll set our API key with the Gemini API key. And in order to retrieve the answer from Gemini, we'll set, so the model we had set earlier to Gemini, and what we'll do is we'll just call generate response here from the model, and we'll feed in the PDF text we saw earlier, which was the State of the Union, as well as our prompt. And our prompt, it can be whatever we want to question within that PDF. So this is the function. Now let's look at the function call. So the model that we have here is Gemini 1.5 Pro latest. That's the one we will be using. And you'll need to call the generative model within GenAI in order to be able to decide which Gemini version you can use, and how we'll leverage our function here, generate responses. We'll just call that, we'll give it the model, and then my prompt here was summarize this in 5 lines, and I printed it. You can play around with different prompts and just really evaluate to see how it's doing and how it's performing against the RAG use case. So just summarize in 5 lines. Definitely a few more than 5, but did a great job there. So it's able to just give you bullet points. It's able to tell you the main kind of motivation behind that State of the Union. So pretty cool job. But that's only with text. Let's also look at it with video here. So in order to do that, what we did here is we've still set that same model, 1.5 Pro, and the response. So what we did here in order to generate content is we gave the prompt, describe the image with a creative description, and we gave it a sample file. And now here, what we're looking to do is we're looking to print out that actual response and end it with just nothing there. And once we've done that, there's a bit of cleanup that we've done here. So this is what the result we get from that. So we're able to kind of see Gemini's creativity here with a different text use case. What it's doing here, it's sketching out innovations. It's creating a nice imagery that we asked it to do here. So very cool to see a different text use case. Now we'll look at the video use case as well with Gemini. And later we'll combine both text and video together and send it to Gemini here. So for the video, what you'll have to do is you'll have to install your packages here as well. OpenCV. Once you have that done, what we actually look to do is we leverage Karpathy's 1 hour long video. Andre Karpathy has a few videos on machine learning. His tutorials are great. So that's what we look to download here. First thing you'll have to do is you'll have to extract the video that's being fed to Gemini as a prompt. And in order to do that, we first cleaned up the existing extracted image frames directory. So just make sure the directory is set up for it to work. So that's what this function was looking to do here. Then we were really looking to extract each frame from the video. That's how Gemini will take it as the input. So in order to extract each frame for the input, we leveraged create frame output directory, the function that we have here. And we sent it our frame extraction directory. So this is the directory that you have set up. For us, it's right here, but you'll modify that for your setup. Then we leveraged CV2's video capture, and then we gave it the video file path. Again, this is something that you'll set up for your video file. Just extracting each frame there, and then we'll output the frame. So we'll, at the bottom, we'll see what it looked like. And you can set in the interval between the frames in seconds. You can really configure all of your different outputs here. So the output prefix, we've replaced the dot with an underscore there. Frame counts, the count there. Then just kind of leveraging through, basically what we're looking to do here is just in this whole function, just extract all of the frames from Karpathy's video in order to feed it into Gemini there. So this is a great helper function that you can also leverage for your applications when you're looking to input video into Gemini. So you can see here the extraction is done at 1 frame per second. And that's what it looks like. It extracted about 500 frames there. So cool to know that. Then what we're looking to do is we're looking to kind of get all of the files uploaded there. So again, another helper function in order to, once you have your frames extracted, then you want to upload them into Gemini. So another just quick comment here, as you can already tell, in order to even prompt Gemini with all of your different contexts, it could leverage quite a bit of helper functions, quite a bit of maneuvering, quite a bit of trial and error. And as you're changing the different inputs into Gemini, you may have to configure the different setups that we've done here. Maybe you wouldn't replace the period with an underscore. Maybe you'll have to change the frames per second. So that's also something to keep in mind that you wouldn't really face with RAG. Once you have your database set up, the setup stays the same and you don't have to maneuver so many configurations as well. So that's what we're actually looking to do here. We're getting the timestamps, we're uploading the files to the API, and we're only uploading a 10-second slice of the file at a time to kind of reduce that upload time. If you want to upload the full video, then you can just change that. But for us, we're doing just 10-second slices at a time here, since it may take a bit of time, and we can see the output here. So it uploaded 10 files, and file uploaded complete. Now we want to list the files uploaded in the API, so we just run a for loop through that, and we can see all of the different files here. Now, what we're looking to do here is we're looking to combine both the modalities to the Gemini's prompt, the text, as well as the video. You can see that right here. So the prompt is summarize the above text and describe this video. Very simplistic. Would love to see all your creativity modifying this and seeing what else you can come up with. So for our prompt, then our final prompt, we've modified it to include the PDF text as well as this prompt. And then to the model, the same model we've kept. And then what we're looking to do is kind of feed that request in with our prompt as well as the files that we have, just a function that's taking in the prompt, the files, and kind of requesting that response there. So this is where the actual stuff happens. So this is where we make the LLM request. So in order to make the request, we'll call our function again, make request, with the prompt and the uploaded files that we have. And we'll also set our, we'll also do generate content with the request that we got. And then request options, we just want to keep a timeout there so it doesn't run forever. And then we'll look to print this response. So we had a combination of two prompts there: summarize the above text and describe this video. So this is the summary of the text that we had, the State of the Union. Did a quick summary there, as well as the video. So for the video, I believe we had changed this. This is not Karpathy's video here. So while we were running our tests, we leveraged Karpathy's video and a few others, and I believe this is a different one. So he's not actually a grumpy looking rabbit. This is a different video. They're all together. But yes, would urge you to try out different videos and different texts as well and see what your outputs look like there. So that was the Gemini use case, and that was everything involved in order to run to run all of this with Gemini's 1 million context length. Now let's look at how we could do the same sort of thing with RAG. So with RAG, we'll just install our packages there. We'll import our libraries, all of that, and then we'll set up our model. And then what we'll do is we'll look to start downloading the file that we're working with. So here we're working with the new sample files .cv, and this is the it's from OpenAI, this sample file that is provided here. And we're just kind of doing the simple setup. We're looking if the file path exists, simple error checking here, just confirming that the file was leveraged successfully. Now, once we have the file successfully loaded, then we need to put it into data frames here. So that's what we're looking to do here. We're just leveraging read CSV, and this is what the data frame looks like. So you can see this is a news content. So it has the title, the description of the news, the label, all of the other things, the label in integers, and then the text label of what this news, and this is just a snippet of the data frame that we're looking at. And if we want to look at a specific record also, this is what the record looks like. This is World Briefing, the first one we just looked at. And here's the description, the label, integer, and then the overall label. And here we're leveraging the shared tier, as I mentioned. So this is where we're looking to configure that database here. And just doing a simple cleanup, drop if the database exists, or create a new database. Simple as that. We created a database for news article with all of the different fields that we wanted. And then what we're looking to do is generate the embeddings. So like I mentioned for RAG, the query that comes in will be embedded, but then also everything within the database, all the different text snippets will also be embedded. So what we're looking to do here is to encode all of the descriptions that we had seen above. And these descriptions, once they're embedded, these are what is going to be pulled out in order to get the LLM the most context there. So just quickly going over this. So you're just looking to put the row in and embeddings and just running a for loop over all of them, setting the rows there. Then let's just quickly look at what the data looks like there. This is where our data looks like. Initially it was just title, description, and the 2 labels. Now, along with this, we also have the embedding of the description. So when the user does a search, finds the embedding, they're actually able to output the text description, which is what will be fed into the LLM. And you can see what an embedding looks like internally. So great visualization there. Now, what we're looking to do is we're just looking to kind of insert into our table and just a kind of a confirmation that it inserted. And our search query here is what we're looking to do. So this is just a quick search query that we're feeding in. We're checking our connection and we're just printing the results of our query there. This is the output we got. This is a quick demo on how the hybrid search also works. So the hybrid search, again, like I mentioned before, it merges both the vector and the text. So here, what we're able to do is our query is articles about Aussie captures, right? This is the news article. So the hybrid query will then look to select all of the different fields that we want, title, description, and we're looking to do a search with dot product here as a semantic score. And this is from our news article table that we generated earlier, and we're just kind of ordering it by combining the scores. And we're just looking to execute the query as such, and this is what the results that we're looking to get. So very cool. And now lastly, what we're doing, the last part of the RAG pipeline is once you have this information, you want to feed it back into your LLM. So for that, we're going to leverage Gemini again. So we're actually using Gemini with a RAG use case here. So just downloading all the necessary packages here. And once we have that, what we'll look to do is we're again going to leverage our generate response function. And with that, we're going to give it the model RAG, which is the model we want to use for Gemini, which is 1.5, our query that we have, plus here we're going to concatenate the resulted string. So this is the query we leverage, and we're concatenating all the results to it as well. And the results is what we got from the hybrid search that we ran before, and it's just casted to a string. So those are the overloaded kind of prompt that we've sent, and you can see we get a response here like we had before with Gemini, with all of the information that it was provided. And then lastly, this is just a quick cleanup. So this is the full overview of the Gemini, leveraging Gemini 1.5 with both text and video, and then leveraging Gemini with RAG and seeing how much, even just within the code, how much simpler it is to use and how much quicker it is to leverage, especially with SingleStore's free tier here, notebook and vector database all in one place. Very easy to use and yeah, very simplistic. So with that, if there's any questions, would love to take them.
Thank you so much, Vanija. That was so informative. Guys, we'll start with the Q&A session. The Q&A button is at the bottom of your console. And Vanija, we have a lot of questions. I'll let Akmal take the lead. And Yeah,
Oh.
like I'm looking forward to hearing.
Uh, so, okay, there's a few questions here. Let me just take a look at this. So Kyriakos asked a question. He's asking, is clustering applied to enhance retrieval processes in RAG models?
Yeah,
I'm guessing
definitely.
yes.
A great question. So there's a lot of different methodologies and a lot of different techniques that you can apply in RAG use cases. You can apply clustering. There's also different chunking methodologies applied. Some people do just chunking based on sentence. Some people do chunking based on paragraph sections or dynamic chunking. So there's definitely a lot of different strategies that you can apply. There's also RAG done with multimodality. There's images, there's text, there's video. So definitely a lot of different strategies you can apply. And I would suggest starting off small and then trying out different techniques and kind of evaluating against your baseline how your models are performing and how your output is looking with as you increase your different kind of technologies that you're implementing within your RAG use case there. Yeah.
Okay, so there's quite a few questions. Let me just see if we can find something else. So here's a good one. Regina asks, what are the limitations and constraints of RAG and how to mitigate it? That's a very big question. So,
Absolutely. Yes. So RAG doesn't come without its limitations. And one of them is that the only context you feed in is the only context you have. So if you have a space that is changing quite rapidly, having your database kept up to date is very necessary. So perhaps in that sense, that's one limitation, that you need to keep updating the database with the frequency of your kind of own organization space updating in order to have the best results. But once you're able to do that, then you don't really have a cutoff of, I only have information up to this date. As you're able to frequently update your database, you're able to kind of ensure that the information is as current as possible. So that is definitely one of the biggest limitations, that there is a lot of monitoring that you have to do there. Yeah.
Okay, I think we've got time for maybe one more question, because I know you need to do the draw and then you need to provide information for the next.
Yes, we have
And
one
as
more
you said a
question.
little bit earlier, we will, any questions that don't get answered, we have a mission to answer 100% of them. So we will get, as long as you didn't ask them anonymously, okay? If you ask them anonymously, we don't know who you are. We can't answer your question. But I think there was one last question. I think a question from Pandy here says, what strengths or techniques do you employ to optimize the performance of the RAG pipeline, especially when faced with complex or dynamic data structures? I think that's another good question there.
Yeah, definitely. For that, I would definitely leverage evaluation. You can look at different techniques, different kind of things that you'd like to do, moving data types, but there's a library, Ragas, that has great evaluation metrics for each step of the RAG pipeline. And I would really look to leverage that. That's the kind of ground truth, and that's the best way to know what is really working well for your application. So for all of the generation, the retrieval pipeline, all of them, there's great different metrics, and I would really look to leverage them and evaluate your entire system end to end that way. Yeah.
Great, thank you very much. I think, Yukti, over to you. We're almost out of time. It's nearly the top of the hour, so I know you need to do the draw.
We
And
just
some
rushed
lucky
through
person
it.
is going to be the winner
Yes.
today. So,
Awesome. Thank you so much, Vinija. This was
yeah.
such an informative session. I learned so much. I come from a non-tech background and even I can learn so much. So can't imagine how useful this is actually. So just a reminder, we have many amazing sessions. I have put everything in the chat and you guys can please go to our resources pages and just see what's relevant to you. I also have a training portal that gives training for free to anyone who's willing to learn. And all right, so if anything sounds interesting to you, please RSVP right now. And so the announcement you all have been waiting for, today's raffle winner goes to Usha Jayaraman, who is the Senior Director of Software Engineering at GE. And thanks for joining, everyone. If that's not you, please do not give up. We are going to announce one more AirPods winner by the end of the day for anyone who has tried out today's demo by entering the raffle link, and they can be eligible to win. And I want to thank Vinija and Akmal for the presentation and the demo. Thank you, everyone, for joining. We really value your time and energy. And have a nice rest of the day. Take care, everyone. Bye bye.
Bye-bye.
Bye. Thank you so much.
Bye.